A wake turbulence is an inevitable consequence of flight. There's been many proposals over the years of, well, why can't you just fix it on the aircraft and make it stop generating wake vortex, wake turbulence, and that's not physically sound. And then wake turbulence separations, in a sense, reduce capacity at airports because you have to add spacing behind the larger aircraft for a safety mitigation. But one size does not fit all. People that fly frequently will notice at an airport, if you fly into Boston, is completely different than if you fly into Dulles. The runways are set up differently. The approach ends are different. There's staggers between them. All of these things factor into wake turbulence research. When the program was doing research back in the early 70s, they used smoke pots, towers with smoke on them, and they'd fly airplanes in front of them. Today we have instruments that I'll show you in a little while called pulse LiDAR, which is a radar laser type of device that actually measures the vortex as it's generated from the aircraft, shed from the aircraft. So I'm going to talk about two specific areas: closely spaced parallel runway operations and single runway and trail wake separation operations. A big focus of NextGen and the FAA is minimum spacing needed. In other words, they're looking at comm, nav, and surveillance. They're looking at datacom, how do you reduce the communication effort level within the air traffic pilot community? How do you improve the navigation of the system? It's good that you did all of that navigation improvement and the surveillance improvement and everything else that goes along with that, but if you don't solve the wake problem, you can't put aircraft closer together. And if this aircraft could not see that aircraft, you had to go single file to the airport to protect the smaller aircraft. Prove that you could run runways separated by less than 2,500 feet here. If you put those smaller aircraft in front of the larger aircraft, you actually reduce the risk of a wake encounter for the parallel runway aircraft versus going in trail. So by placing an aircraft in a staggered position, it had less risk of a wake encounter than if you put it single file to the same runway. The FAA also looked at a departure scenario, and they developed what's called wake turbulence mitigation for departure. If the wind is blowing this direction, this wake, for the most part, cannot transport against the wind and get over to that runway. It measures the wind and determines when these conditions exist, and then it presents a controller what we call a red light, green light. And it allows the controller then, in a green light situation, to depart that parallel runway aircraft without delaying it 2 or 3 minutes. FAA talks about doing dynamic pairwise separation standards in the future, and that's where the aircraft weight configuration, the weather conditions, the met conditions at the time of arrival or the route of flight are all taken into account, and then they develop a separation standard for that specific scenario. So one day you might be 4 miles behind an aircraft, the next day you might be 3 miles behind the aircraft because the configuration, the weight, and the met conditions of where that separation is being applied. Next thing I will talk about is basically single runway type solutions that the FAA has done that we're supporting them on. The FAA had categorical breakpoints by weight of aircraft types, and they split these categories into the heavy category into 3 different levels. But they've realized at least 10% capacity benefit by putting this recategorization in use at Memphis. But, it is a significant capacity benefit for an airport.